Okay, we have a situation where fluid is moving at 5 meters per second in one part of a pipe, and then at some other speed in another part of the pipe. The cross-sectional area at the first point is 0.02 square meters, and at the second point it's 0.0067 square meters. Now that's 1/3 of that to the round off and so forth. Okay, so we have less cross-sectional area over here than we have over here, and that's going to cause the velocity here to be greater than it is here. Now why is that? Well, it's because fluid can't compress. We assume the fluid can't compress. I mean, fluids can be compressed, but not very much. And unless we have extreme pressure changes, that's not something we worry about. The amount of fluid, since the fluid can't be compressed, fluid can't accumulate any place within this pipe, because if it did, it would become denser at that point, and that can't happen because it can't compress. So the amount of fluid passing one point, and let's just say passing this plane in this pipe in a given time interval, has to be the same as the amount of fluid that passes this point over here where the cross-sectional area is less. Now how can that be in the same time interval? Well, it means that if in that time interval, let's say the fluid travels this far here, over here, in order to have the same volume in the same time interval, it's going to have to travel quite a bit further. In fact, if you have 1/3 the cross-sectional area, it's going to have to travel 3 times as far. So, and these, equal, I'll write equal delta t to indicate we have equal time intervals here. Well, what that means then is that V1 delta t, which is how far the fluid travels here, multiplied by the area, cross-sectional area at this point, gives us the volume of fluid that passes this point in time delta t. And let's back up a second, because this is just using the principle. V1 delta t is how far the fluid travels. Cross-sectional area is the area of the cross-sectional area of the pipe at this point. So the pipe is going to be, well, the volume of the fluid is going to be a cylinder with that cross-sectional area and that altitude. So we have this volume. Okay, so this is the volume of fluid that flows in time interval delta t. Now, in the other part, we have excuse me, V2 delta t multiplied by the cross-sectional area A2. And we'll say the volume in delta t is the same at both points, which gives us the equality. So that V1A1 equals V2A2. Just dividing the delta t out, it doesn't matter. These ratios are going to be the same regardless, or this product is going to be the same, and these products are going to be equal regardless of the delta t that you use. So we get V1A1 equals V2A2. That's called the continuity equation. And of course, if you read the solution to the introductory problem set, you can see that. Okay, well, to answer the question now, the question is, what is the velocity V2 here? And we easily use this idea, this proportionality. We can use this as an equation without even understanding it, but best to understand it. If you can possibly avoid it, don't use an equation you don't understand. If you're desperate, then take the chance, but try not to put yourself in a position where you're desperate. Okay, so we got V2 equals V1 multiplied by what? Okay, well, V2 is going to be bigger than V1. We're going to multiply by the one area divided by the other. Okay, this area is 1/3 this, so if we divide this area by this, we're going to get the factor by which this length exceeds this length, which is the factor by which this velocity exceeds this velocity. So we're going to multiply that by A1 over A2. Of course, we can always take this and do the algebra with it. Solve for V2. You're going to divide both sides by A2. That's exactly what you're going to get. So that's equal to what? The 5 meters per second velocity, V1, multiplied by what? 0.067. Oh. Now I just messed up. Let's fix that. Got ahead of myself and wrote something down without thinking. Try not to do that yourself. Okay. A1 is, of course, the 0.02 meters squared. And A2 is your 0.067 meters squared. A couple of significant figures. This divided into this is 3, and you end up with 15 meters per second. An application of the continuity equation, but more importantly, an application of the common sense idea that the volume here in a certain time interval and the volume here in a certain time interval have to be the same. Since the cross-sectional area here is 1/3 of what it is here, the velocity here has to be 1/3 of what it is here, so this velocity is 3 times this velocity. I suggest you think about that until it makes really good sense.